today's training, you'll be able to describe the operation of a diesel fuel system, explain the critical nature of fuel temperature and water and their effect on diesel engine operation, list the steps required to keep your truck running properly, and be able to start a diesel engine that has run out of fuel. In 1885, a laboratory assistant by the name of Herbert Ackroyd Stewart was checking the progress on his molten metal project. He was using a kerosene lamp to illuminate his work when he accidentally spilt kerosene into the molten metal, which turned it into a vapor. The rising vapors from the molten metal rose up and hit the flame of the lamp. Learning from this experience, he went on to develop the concept of spraying an oil mixture into a piston chamber, igniting it by the hot air created in compression. If Stewart could only see the results of his discovery today. Diesel engines are one of the most efficient internal combustion engines used in our industry. Diesel engines operate under a law of physics. Simply put, when air is compressed, it heats up. Diesel engines operate with a much higher compression than gasoline engines. The air inside the cylinders at the moment of combustion approaches 1,000 degrees Fahrenheit. At that same moment, vaporized fuel is injected and it ignites. The higher compression allows more complete burning of the fuel when injected. This process is more efficient, increasing fuel mileage and horsepower. A typical fuel system consists of 6 critical components. Using a Detroit engine as an example, fuel is drawn from the fuel tank through the primary fuel filter to the fuel pump, where it is pumped at approximately 60 psi through the secondary fuel filter into the inlet manifold. At this point, the fuel is divided and a portion is delivered to the injectors, while the remaining fuel is used to cool the injectors. The fuel used to cool the injectors is returned to the fuel tank for recirculation.